This podcast is sponsored by Oracle. Experience easy, rapid, and agile deployment of any Java EE application using Oracle Java Cloud Service. Gain full control and flexibility of your applications in public cloud. Learn more by visiting cloud.oracle.com.
Welcome to the InfoQ podcast. The InfoQ podcast is produced by the practitioners behind InfoQ.com, an online community focused on senior developers, architects, software leaders who drive innovation with software. On the site, you can find news, articles, conference presentations, and of course, podcasts on innovator and early adopter topics that affect software today. My name is Wes Rice, and I have the incredible privilege to chair QCon San Francisco, QCon New York, and the upcoming QCon London on March 6th through 8th. QCon, like InfoQ, is focused on bringing you deep, meaningful lessons from the world's most innovative software shops. Today, I'm joined with a frequent speaker and friend of QCon, Kolton Andrus. Kolton is the CEO of an early-stage startup based in the Valley named Gremlin. Before Gremlin, he was a senior software engineer at Netflix, where he was a member of the Edge platform team. That's the part of the infrastructure where public streaming requests terminate before being served by the microservice architecture that we all know and love from Netflix. At Netflix and now at Gremlin, Kolton has been focused on the idea of fault tolerance and anti-fragility in distributed systems. Today, we're going to talk a bit about that. So, Kolton, welcome to the InfoQ podcast.
Thank you very much. It's my privilege to be here.
When you talk about Gremlin, I hear you most often talk about it as failure as a service. So I'm envisioning like I go register some key out there, and then you just start randomly causing havoc on my servers. What does it really mean when you talk about failure as a service?
Yeah, it's kind of like what you've described. Failure as a service is really about causing the kind of common failures that you see in production on purpose. The difference being, instead of them happening randomly or in the evening or the middle of the night, heaven forbid, we can cause them in the middle of the day while everyone's paying attention.
So is it like software as a service, or is this an agent I put on my servers? What's it look like?
Yeah, so we've built Gremlin to be failure as a service, software as a service. And we have three main pieces. We have an agent that runs on the boxes. It's a compiled binary that works on any Linux box that causes the bad behaviors. We have a control plane, which has some safety features, things like dead man switching or reverting impact if things go wrong. It has an API that sits on top of it. So we are able to integrate with continuous integration, continuous deployment, allow people to make this part of their normal build and deploy pipelines. And the last piece is a web interface. I think that good developer tools are really about making it easy for people to do the right things. And I think a simple, powerful web UI that guides people through a kind of complicated and scary topic like failure testing and helps them to arrive at the right outcome.
Yeah. When you say failure testing, I mean, is this like kill-9 on a running server? What type of things are you actually causing to happen?
Yeah, so the V1 of Gremlin is focused on infrastructure-related failures. Things like a noisy neighbor, there's CPU being used on your box, a JVM leak, memory is being consumed. Yeah. Network bad behaviors are classic. You lose a dependency, you can't talk to it anymore. One of your upstreams gets slower and takes seconds longer to respond. Or perhaps you just see a network partition or packet loss.
So when I was doing a bit of research before we chatted, I ran across a IBM package called Gremlin. That's not what we're talking about, right? This is something separate, right?
Right. This is different. So it turns out Gremlin is a good name because it's intuitive in the failure injection space. For people that don't know, the Gremlins were the little green monsters in the pilots' airplanes in World War II, and they would cause it to break, and the planes would crash or they would have troubles. So Gremlin is a good intuitive name.
How do I find Gremlin Inc.?
We are Gremlin Inc., and the website is gremlininc.com.
So what we're talking about, the failure that you're inducing, these are production servers, right? You're talking about.
Yeah, that's the goal. The goal is to end up in production, and certainly that's where you get a lot of value. That being said, you start by running this in test or in dev and building your confidence and then working your way up to production.
So that kind of leads me to a question that's probably in the back of everybody's mind. If I'm trying to sell this to my VP, how do I convince her that I'm not going to just completely upset every single one of our customers with these self-inflicted gremlins running about in our systems?
Yeah. Well, that's part of the reason why we're building Gremlin. If you look at a lot of the open source projects that cause failure, and there's a good handful out there, they tend to be libraries or isolated pieces that just break things. And that's fine. It is a little harder than you might think to break things on purpose, but you can go out and cause that. One of the things that you need is you need the ability to revert that impact, to clean it up. You need to have a set of fail safes to make sure as you're running these across your fleets or across different components of your system that if things go wrong, you can revert them and clean them up. So I think that's the first part is, what we're helping people to have is some safety and some peace of mind in running what sounds like a scary proposition. In terms of explaining it to VPs and executives, I love the analogy of the vaccine. What we want to do, and it seems counterintuitive, just like in the health world, is we want to inject a disease into somebody in order to let them build an immunity to it. Well, we want to do the same thing in production and in our environments. We want to inject these bad behaviors to build an immunity to them, so that when we do see these regularly, these failures that occur on a semi-regular basis in production, we're immune to them. We've already tested that we gracefully degrade and that they're no ops instead of being, pager duty incidents.
Yeah, that's a great analogy. I love that. So your software as a service, you've got an API, you've got a web interface. I think you told me before you've got a CLI that you talk to. You've got an agent that runs in my box. What other types of questions might I have as an architect if I want to integrate with a system like Gremlin?
Well, some of the questions we get are about safety and security. Those are things that we take very seriously. We have from day one. So we have a lot of those kind of features built in, things like auditing. We know every action that's taken on our API or through the web UI. It's things like the automatic cleanup and rollback if things go wrong. Gremlin doesn't need to run as root, so we're able to solve that problem. We only take the Linux permissions that we need. So we've been very conscious that the clients and the agents all have to authenticate to run attacks, and they get those privileges can be revoked. If they get revoked, they'll automatically clean up, and they're not allowed to execute new attacks. So some of those safety concerns we've really thought through and are pretty key.
How old is Gremlin now?
So my last day at Netflix was January 25th, and we started building Gremlin the next week. So 9 months here.
Oh, wow. So just 8 or 9 months. That's awesome. Congratulations.
Thank you.
Any big success stories so far that you can humble brag about?
Well, so we just launched our closed beta 2.5 weeks ago. We have several big name companies. I'm not going to talk about any by name, but several Valley companies that are large, that are very interested in using Gremlin, that have installed it, that are starting to play with it. We're excited as well for our open beta. So closed beta is going to run through the end of the year. And then when open beta comes at the end of the year, we're going to find some new customers, some new people to try it out and to play with it.
Sweet. All right, so you brought up Netflix. So let's talk a bit about some of the work you did there. The very first time I met you was just before QCon London in 2016, where you did a keynote with Peter Alvaro from UC Santa Cruz on some of the failure injection work that you're doing at Netflix. And I specifically remember after that talk, Adrian Collier from Morning Papers talking about how it was one of the best, if not the best, keynotes that he ever heard. That's some awesome geek cred there, by the way.
It's very kind of him to say.
In the talk, and I think you also co-authored a paper with Peter for the ACM Symposium Cloud Computing that really talked about this stuff. But all this was about LDFI. What the heck is LDFI?
Yeah, lineage-driven fault injection. It's a mouthful too. Is this technique that Peter came up with while he was at Berkeley. And it was kind of an eye-opener. It was kind of an aha moment when I read his paper, because the crux of it is, instead of looking at all of the things that could go wrong, you look at something that went right and you ask what could have prevented that.
Okay.
And in essence, you limit the entire search space right there by a large amount. And then he applies some satisfiability. We convert this provenance into a conjunctive normal form, and we pass it through a satisfiability solver, and it tells us what it thinks are the combinations of failures that would break the system. And what we do is we go through those assertions and we test them with real failures. And if it results in a customer-facing error, we found a bug. if it doesn't result in a customer-facing error, we can eliminate that not only from this experiment, but from future experiments. And so from that, we're able to take an approach to give you some real metrics. An example, we ran this on the app boot, the startup request at Netflix devices. There are about 100 services that request touches. To test everything in a brute force nature would take 2 to the 100 executions, or a 1 with 30 zeros. Using this approach, we were able to fully explore that space in 200 experiments.
Wow, that's crazy. So you said you look at something that would be successful, and then you look at all the possible things that would prevent it, and then you just keep repeating this. So is it like a rule engine that looks at what would stop that from happening? Is that how you kind of build this out?
The crux there is redundancy. You're essentially looking for a redundant functionality or redundant capability in the system that steps up when you inject a failure at a specific point. One thing that we learned about the work at Netflix, in Peter's world, he kind of knows perfect information, and he can do a lot of pre-processing to find that redundancy. In the Netflix world, we have redundancy. We have servers and data centers and regions, but in the code, you don't see that redundancy up front. But as we inject failures, we see things like Hystrix fallbacks, or we see subsequent services that step in and fill that need, or maybe cache data that serves the same purpose. And so from that, we can find out if we really need that functionality or if that redundancy is inherent in the system.
That's cool. So you talked about one of the use cases. You talked about some of the metrics. What other lessons did you learn from Lineage-driven Fault Injection at Netflix?
Well, one lesson was just that it's easier to approach academics than I thought. A little background story here. I was watching Peter's talk, a keynote that he had given on LDFI, and I thought, wow, this is awesome. I really want to learn more about this. And so I blind emailed his Berkeley, cs.berkeley.edu email addresses. I tried a couple, and I got an email through to him, and I said, hey, let's grab lunch. Peter's a really nice guy. We met in the city. We got lunch. And, what's funny is as we reflect backwards, a lot of times that's where the academic industry collaboration ends. Is you meet, you have lunch, you're like, that's cool, and you go your separate ways. What was cool here is a couple weeks later, Peter reached out to me and he said, hey, could we build this together? Could we build this at Netflix? And so I make the joke, Peter was my professor intern at Netflix for a summer. And we got together and we got to take, all of the theoretical parts of his paper and figure out how to make them work in the real world. And I won't go too much detail there. Our talk goes into some of the trade-offs we had to make and why, what we learned from that. But that experience as a whole was an awesome opportunity. I learned a lot, and I made a new friend and a new peer in the industry.
Yeah, that's really cool. Do you recommend that developers get out there and not just read papers, but actually start having coffee, having lunch with academics?
I think it's mutually beneficial for both parties. On one hand, as a production engineer, sometimes you're just trying to keep the lights on. You're trying to solve your current project. You're trying to deal with the pain of the day. And it's nice to be able to look at big ideas that you haven't maybe thought of and could apply. The flip side is true as well. As an academic, Peter had these ideas. In his approach, success was just an arbitrary concept. And he didn't really have to measure success. It was just, did it succeed or not? In the Netflix world, success is all about the customer. Did the customer succeed? Did it work well? And so now Peter thinks differently about how he measures success. He thinks about the customer, and he knows that that's an important element in production systems.
So we've been talking about failure and kind of failure injection, and specifically about lineage-driven fault injection. Why is failure injection so important today in a microservices world?
I think there's two parts. One part is as you scale up and you start running more boxes, more instances, more of the time, you're just going to encounter failure more often. You do the statistics, you do the math, the things that sound like they're astronomically low start happening on a regular basis. So you just need to be prepared for that failure. The other side of things is it's an opportunity to train. As we move to a world with kind of the DevOps focus where you build it, you own it, you operate it, you're on call for it, you need ways to know that it's going to work the way you expect. Nothing's worse. Actually, I enjoy getting paged at 2 a.m. So this is a little bit of a lie because I'm weird. But nothing's worse than getting woken up and having to, groggily eyed try to figure out what's wrong with your system. What we found by applying this at Amazon and at Netflix is that if we go through and we cause these failures, even the simple low-hanging fruit, and we see what happens and we ensure that it gracefully degrades or it handles in a way we expect, then we don't get paged when those things happen. We've had several incidents where we did this at Netflix. We tested one of our downstream dependencies failing, and then a week later, 2 weeks later, that service goes down. They get paged. We don't end up getting paged because there's no customer impact, and we end up talking about it the next morning at 9 a.m. over coffee instead of complaining about it at 9 a.m. over coffee.
So I asked you earlier how kind of version 1 of Gremlin kind of protects the customer traffic so that customers aren't seeing these failures. What are some of the things that Netflix does? How does Netflix kind of canary off this request or isolate some of this traffic so that it's not affecting users when failure happens?
Yeah, so to be clear, you can cause customer impact. And if you're doing it right and in production, you may cause some customer impact. The difference is that you're watching carefully and you quickly roll it back or revert it if things start to go wrong. So you may end up with a 1-minute outage or a 30-second outage that if you hadn't run it and tested it would have been a 15 or 20-minute outage in the real world, because people have to get engaged. They've got to log on. They've got to look at the dashboards. They've got to figure out what's wrong. Yeah,
it totally makes sense. And it also is happening, like you said, it's in the morning. It's 9 a.m., 10 a.m. It's not at 2 in the morning when people are being woke up. So that's really cool.
Yeah. So part of what you were asking there about how Netflix causes or how we were able to run these safely. So at Netflix, when we built this system, we built it at the application layer, which is a little different than what I described with Gremlin. Gremlin's V1 is infrastructure related, and Gremlin V2 is going to have this application functionality that we built at Netflix. But what that allowed us to do is to have request level fault injection. We could inject requests for a specific user, a specific device, or a percentage of users. And so what we would do when we'd want to test a failure is first we would test it for our own user, just a sanity check. Does it work? Or because if it fails, you should stop there and fix it. And then we would run it for, some real devices in the lab, and we'd see if those devices handled it well. And then we'd move to running it in production, but we'd run it for like 0.01% of traffic. Right. And we'd see how things behaved. And then we'd ratchet it up and we'd step up at each function. So then we'd go to running it for 1% of users. And if at any point things go wrong, you shut it down, you debug it, you find the bug, you fix it, you start over. But if things go well and your confidence increases, then you increase that failure scope. So once you know 1% of customers are good, you run for 10, you run for 50, you run for 100. And the goal is to run a failure at 100% in production, because then you really know that you can handle that flavor of failure at scale.
Yeah, and you take metrics initially and then compare the metrics at that like 5% or 10% to make sure that you're not seeing some increased number of whatever badness you're trying to cause, right?
Absolutely. I grew up at Amazon. Metrics was how we lived. You had to measure everything. And so part of good failure testing is, having dashboards, having your alerts, having your paging, verifying that those work the way you expect, but also using those, leveraging those. So one thing we don't do at Gremlin, we don't try to automatically determine your metrics. We don't try to provide you with metrics. One of the value propositions is that you see how your metrics behave when things fail. You have an opportunity to test that your alerts work. You can test that you get paged like you should.
So sure, but there's definitely some patterns and some practices. There's some smells there that you have some experience. So what are some of the things that some metrics that at the OS level that I might want to be watching for this kind of a failure you're inducing?
Well, so the most important metric for all of these is like the top key performance metric for the business. So in Amazon retail, it's can people order? And if that order metric, it's called an order drop if there's an outage. You never want those. So that's the metric that is first and foremost. At Netflix, it's can people stream? And so if we see a drop in people unable to stream, or we see a drop in active sessions, we know that we've caused some problem. That's our first indicator that we need to stop. And then you drill down. So that's your top level. You want to look at your service metrics. Are your API calls working correctly? Has your throughput changed? What does your load look like? What does your memory profile look like? On the box, within the service, are individual boxes in trouble, or are they behaving well?
Makes total sense. Any particular tools or anything, tracing tools or anything in the observability space that you recommend for people, or is it pretty much wide open?
So, on one hand, I think just the same ops tools that people use for incidents are what you use, and that's what you want to use, because part of the value here is preparing. That being said, I think there's a lot of value in tracing infrastructures, similar to Dapper or Zipkin. Netflix has one as well. We integrated the failure injection at Netflix with the tracing system. And so when we would decorate a request with failure, or when we'd cause a failure, we could see all of the points in the system that request touched. And what was great about that is that showed us what could fail, or at least what we'd instrumented that could fail. And so from that, we could learn about what might be interesting failure modes to cause, or we may find a dependency we didn't expect that we weren't preparing for.
That's really solid advice. Cool. So Netflix runs like 1/3 of internet traffic. Is this type of work that you're talking about, is it really only for the big boys? If I've got a farm of 36, 24, 12, is there some point of diminishing returns, or do you think this is as valuable for the small shops as it is for the big shops?
I think that really comes down to the question of what's the cost of being wrong. And I think back to your early question, how do you sell this, or how do you convince your higher ups or your executives that there's value in this approach? And I think with most things in the business world, you tie it back to the money. So what's the cost of being wrong? There's a couple interesting statistics out there. An hour of downtime for Facebook is estimated to cost $1.7 million in lost ad revenue.
It's crazy.
So right there, that's worth a team's time in the least. When we were at Amazon on the e-commerce world, if you're down, you're not taking orders, you're not making money. And some days matter more than others. If you're down on Black Friday, it's that time of year. Yeah. If you're down for an hour on Black Friday, it costs you much more than it would other times of the year. So really thinking about that cost of being wrong. Some other things that we think about: do you have SLAs? What is the cost to your business if you're down? What's the cost to your brand? What's the cost to your customer trust? How do you feel about your product if it doesn't work? So those are other less tangible metric, harder to measure, but still important attributes.
Yeah, absolutely. So say I want to get started with failure testing. Obviously, I should go out, create an account on Gremlin, start using Gremlin. Obviously, I should do that. But let's say I just want to get started. What's like level one? What's some of the first steps for getting started with automated testing?
Well, if you want to just get your feet wet and test or dev, just go break stuff. Take the Chaos Monkey approach, turn off some instances, just start mucking with things.
What about level 2? What's the next step?
Yeah, I think where you go from there is it's hard to take that approach and apply it in production. Yeah. One of the things I mentioned earlier, some of these open source products just aren't mature enough to run safely in production. And so that's where we think we provide value. We want to make it easy for people to run these in production. We want to make it safe. And so we want to give people that kind of tooling, that infrastructure.
And then finally, what's the master's class? What's the next step that's really pushing the envelope with? Is that lineage-driven fault injection? What's pushing the envelope now?
Yeah, for most people, I think the master class is just running it in production. Even running a simple failure mode. Take out one service in production and see how things happen.
Right.
I didn't talk about it much earlier, but running in production should be everyone's end goal, because that's the configuration that matters. Those are your mitigations that work. Those are the things that, that's what matters to customers is production. And so if you test and things are different in prod, you won't be prepared. So I think just being able to run failure tests at scale in production is currently pushing the envelope. If you were to ask me a year or two down the line, I'll tell you that my V3 plan for Gremlin is automatic failure testing. It's to take lineage-driven fault injection and just do it for people. But we're not quite there yet.
Oh, wow. So speaking of Gremlin, what's next? You've got V1 out. It's been 8 or 9 months. What's next for Gremlin?
Yeah, so a couple of the cool product features that we're working on are really about helping teams train for operational readiness. The first one is testing engagement. So the ability to, you're on call for the first time, or let me back up. You want to test engagement because I've seen a lot of outages where the incident was twice as long as it should have been because someone didn't get paged or an alert didn't go off or something unexpected happened. So step one, let's just help people test that. You have some metrics, you have some pages. Let's set up some failure tests that happen on a semi-regular basis. Let's trigger those, and then let's measure how long it takes someone to get involved and to resolve it. And from that, we can get a proxy about what's our mean time to engagement, what's our mean time to resolution look like. Beyond that, the next one, it kind of builds upon that concept. We really want to help train new team members or help train teams that are new to this kind of operational readiness. So what we've thought of is this red team, blue team idea. The blue team's the new engineer, the red team's the bad guys, the other engineers or team members. And they're going to think up some interesting failure mode, and they're going to spring it on that person at an unexpected time. And that new engineer, it's going to be during business hours. Obviously, the rest of the team knows about it, so there's a safety net in place. But that engineer is going to get paged, alerted. They're going to have to check their dashboards. They're going to have to look at their hosts. They're going to have to diagnose the problem and then ultimately resolve it. And so from that, what we have is we have a way to really help people prepare for their on-call rather than just, I don't know how it happens at other companies, but at Amazon, it was kind of like, hey, here's a run book that might be out of date or it might not. When you get paged at 2 a.m, good luck.
Yeah. Yeah, that's really cool. I've heard some conversations over the last year about people talking about how do you train operations folks? How do you get them ready to take the pager? So that's really cool. That's a cool idea.
And then the last product feature that we're thinking about is just how do we help run these large scale failure tests? It's one thing when you're doing, one for your service or a smaller scoped one, but when you're running a company wide one, you need to think about some of these things we've discussed. What are the metrics that will indicate customer impact? What are our abort conditions? We didn't talk about this earlier, but we should always have an abort condition for your failure test. If things go wrong, you want to abort right away. How do you communicate with other people? How do you let other people know that that they might be impacted or a test is going on? There's some fun product features here, like a little Slack bot that lets people know a failure test is being kicked off. Some thoughts about some post-mortem questions. Did it work as you expected? Did you find any bugs? If you found bugs, maybe you want to follow up and run this a test in a week or two to validate that you fixed those bugs. Maybe you want to run this test, then maybe you want to automate this test so it runs all the time so you don't regress and drift into failure.
Very cool. So we've been chatting with Kolton Andrus. You can find his presentations on infoq.com and information about his company Gremlin at gremlininc.com. Now, you mentioned earlier that you're in closed beta, but you're about to open that up, right?
That's right. Start of the new year, we're going to open beta up. And anyone that's interested in hit our website and sign up, we'll reach out to you and engage you as such.
Well, cool. It's great learning about Gremlin. If you want to be a part of QCon and hear from practitioners just like Kolton, there's an upcoming conference March 6th through 8th in London. The attendee ratio at QCons are 11-1, so you have great access to thought leaders like Kolton. So please join us. Kolton, it's always great to catch up with you. I'll see you at the next QCon.
Thank you very much.